In this problem, we're being asked to find all of the points on the curve f of x equals x to the power 5 minus 1/3 x cubed, where the tangent line is horizontal. So, first things first is I want to find where the tangent line is horizontal. What does this mean? Well, I know that the tangent line has something to do with the derivative, right? So the slope of the tangent line is the derivative. And I know that if it were to be horizontal, right, think about a horizontal line here, horizontal lines have a slope equal to 0. So what it's asking me to do is it's asking me to find the points on this function, on this curve, where my derivative is going to be 0, right? So the tangent line being horizontal means the derivative is going to be 0. So what I'll go ahead and do is take the derivative of my function. So we need to find f prime of x. And then I'm going to go ahead and set that equal to 0. So the derivative of this using the power rule would be 5x to the power of 4. Drop the 5 down, take 1 away. Same thing here. 1/3 times 3 is going to be just a 1. And x drops down a power from 3 to 2. So now I need to set this equal to 0 because I want to find where the slope of the tangent line is going to be 0, right? Or the tangent line is horizontal. To do this, I would factor out an x squared. So whenever I have kind of a couple terms and it's equal to 0, sure, we could go ahead and take our x squared, add it over, try and solve it that way. The only risk we do when we take that approach is we risk forgetting that when we divide by the x squared term to simplify this basically, or even x4, um, you're going to divide by 0, right? X has a restriction there where x could have been 0 and you would have been dividing by 0. Generally, when we do that kind of process where we start moving things around, we lose that x restriction. And so what I like to do instead is I'm just going to go ahead and factor out an x squared. So the biggest, highest power that these terms have is 2, at least in common. So I take that out. Obviously, you can't pull out 4 from something that has 2, right? So I'm going to pull out the x squared. I'm left with 5x squared minus 1. And what this tells me is that either x squared equals 0, or it tells me that 5x squared minus 1 is going to be 0. X squared being equal to 0 means x is equal to 0. 5x squared minus 1 being equal to 0 means that x squared is equal to 1/5. So you add the 1, divide by 5, and then this leaves me with x is plus or minus root 1/5. Therefore, these are the points where my function f of x would have tangent lines that are horizontal.